This video lesson is on factoring by grouping, which is a method of factoring used on polynomials with 4, 6, 8, 10 terms. In fact, any even number greater than 2, although all the examples that we'll see today will have only 4 terms. And as an introduction / a reminder, because this is one of the steps that we're going to need in the procedure. In this first example with these 3 terms, this one, and this one, this, by the way, is 1 term because there's a number multiplied by a bracket. It's not considered 2 terms. This is 1 term, and this whole thing is 1 term. What's the GCF, the greatest common factor of these 3 terms? Well, the answer is x plus 1. Even though it is in brackets, that's considered a factor, and it's common to all of these. And if you want to try in this set, if you want to pause it and think about it, the GCF here is, there is a 3x minus 2 in each one of these terms. There's also at least a 4. The GCF here is 4 brackets 3x minus 2. So that 3x minus 2, even though it is itself a binomial in brackets, that is the common factor. So this skill, this idea, being able to recognize that that's a common factor, that comes up in the procedure. So here's how you go about factoring by grouping. You should always look for a GCF first. Before you do anything else, any other method of factoring, you should look to see if there's a GCF of all the terms. Then, for a polynomial of 4 terms, you group by breaking up the polynomial into 2 groups of 2 and factoring out the GCF of each group. So here's how we do it. Step 1 is to look for a GCF of all 4 terms. If you want to pause and think about that for a second, you can. In this case, there is no GCF of all 4 terms. So I move on to step 2, which is to break the polynomial into 2 groups of 2 where each group has common factors. There are different ways to do this usually, and it'll lead to the same final answer. But I chose to break up my 2 groups like this and this. If you had, let's say, decided to group the 2a cubed with the 4a, and the 7a squared with the 14, you also would have gotten the correct answer just in a slightly different way. But for now, I chose to group them like this and like this. And from each group, I'll factor out the GCF. So the GCF of this group here is a squared. When I factor that group, I'd get a squared, and what would be left is 2a plus 7. And in this group, my GCF is 2. When I factor that one, I'm left with 2a plus 7. This sign in here is really important, because even though I'm factoring out 2, I always have to write a sign here, because I'm not multiplying this whole thing by 2 and then another 2a plus 7. I'm adding the GCF times a factor. So whether it is a plus or a minus, I always have to include a sign here between my 2 sets of factors. And the very final step is to factor out this, which is now a common factor of both of these. So these have to be the same in this procedure in order to do the next step. And if they aren't, it means that you have made an error somewhere, and it means that you might have to take out a different GCF, or it might mean that you have to group your terms differently. But in this case, because we do have a common factor, that 2a plus 7, this is the intro thing that we did, it means that I can factor out the 2a plus 7, and what I would be left with is a squared and plus 2. And that is the fully factored version of the original. That a squared and the plus 2, like I said, is what was left over from the original terms. And that is the final answer. So we'll try another example. Step 1 is to look for a GCF of all 4 terms. If you want to pause and think about that for a second, you can. In this case, there is no GCF. Step 2 is to break this up into 2 groups. So if you want to, again, pause and think about how you want to group them, go ahead. In this example, I grouped them again, the first 2 together and the last 2 together, and it won't always be like that, but in this case, that grouping will work. When I factor out each group, again, if you want to pause and give that a try, I'll take out the GCF from each group, and here, this is what I get. I took out a 7x squared from these 2, and I took out a 2 from these 2. Now notice that these 2 brackets are not exactly the same. They're almost the same. This one has a positive 5x and a negative 8. This one has a negative 5x and a positive 8. They're not quite the same. And the very first thing that I can do before I decide that I've made a terrible error or before I decide to give up is I can try to choose my GCF differently. Like here I chose 2 as my GCF. But if I had instead tried -2 as a GCF, and that's not a coincidence, like if these are both even numbers, there's possibly not a greater common factor, but by changing the sign, I can change the sign of these terms, because when I divide -10x by -2, I'm left with 5x, and when I divide 16 by -2, I'd be left with -8. And now these two factors do match, and I can move on to step 4. And when I remove that common factor, I'm left with 7x squared and -2, and this is the fully factored version of that original 4-term polynomial. Example 3, if you want to pause it and give the whole thing a try from the start, I encourage you to do that. But I'll go through them step by step. Step 1 is to look for a GCF of all the terms. If you want to try that on your own, you can pause for a minute. Here there is a GCF, and it is 2. And now I'm going to leave that 2 outside and group my inside terms on their own the way I did before, but I'll keep that GCF written outside. So I group these like this. Group 1, group 2. If you want to pause and try to factor out the GCF from each one, I encourage you to do that. This is how they factor. And I do have the same common factor in both cases, that b plus 2n. So I'll factor this inside these brackets part the same. I'll have a b plus 2n, I'll have the remaining terms, but I'll have a 2 outside that remains, and these brackets I no longer need because everything is being multiplied together here. And that is the final factored version. And one final example, step 1 is to look for a GCF of all the terms. Again, if you want to pause and give this a try, please do. In this case, there's no GCF. So to break this up into 2 terms, in this case, it would not work to group the first 2 terms and the last 2 terms. Sometimes you have to group them differently. And the way to do that is to scan around to see if you can find some things that have a natural GCF, like these 2 terms both have x's. You could choose those. Also, these ones here both divisible by 5, and they both have a y, so those could be good choices too. And these ones here are both divisible by 6, and they both have at least 3 m's, so they both have GCF, so I'll group them that way. And when I factor out each group, I'll just write this blue set like this. The common factor is 5 and y. I'd be left with x and plus 2m. And for these ones, my GCF would be 6m cubed. I'd be left with 2m plus x. And these 2 things here are actually the same, even though they look a little bit different because I'm adding a positive x and a positive 2m, and here I'm adding a positive 2m and a positive x. In that case, the order doesn't matter. They are actually equivalent factors, so I can factor that out. And this is how that factors. And that is the end of this video lesson. Thanks for watching.